Yes, sir.
Let's look at Rother's method again. Normally,
Okay. Sir, sorry,
yeah,
sir. Please don't forget to share the other videos that you recorded.
yes, I'll do that again.
All right, sir.
All right, so first step that we do is we calculate E Rother. And that is V plus IA RA cos phi. All right, so now, once we found that, we go to E Rother here. And then we want to know what the excitation is that caused that voltage. And that will be F open circuit. In other words, the MMF needed in current, because this is the field current, and that's the induced EMF. And then we can draw another graph, which we normally draw on the same scale, but it doesn't matter. So now we can say I short circuit, and again, F from field. So let's say that. All right, let's say now we find I short circuit full load. I full load. We can either determine that by S is square root 3 V line I line, or P is equal to square root 3 V line I line cos phi. Now, then we look what is the excitation that causes that, which is then called F short circuit. Then we calculate F resultant. In other words, what is the sum of open circuit and short circuit excitation? So that will be F open circuit at an angle 0 plus F short circuit at an angle of 90 plus or minus phi. Okay? So now once we've got that, then we go back here and say, all right, that is F resultant. And then we go up and find what is the voltage there. That'll be E resultant. And now you've got that, then you can say the voltage regulation is equal to E res minus V over V. And that is all there is to Rother's method. Nothing easier. What normally confuses the students is if I draw these two graphs together. But it doesn't matter whether you do it separately or together. Does that make more sense?
Yes, sir.
Okay.
Yes, sir.
Anything more about alternators? Can we talk about the power again? Because this is important. If you're going to advanced BTech, then advanced diploma, then you're going to do this again. So if we look at the phasor diagram of an alternator, then we can say that E angle delta is V angle 0 plus IA ZS angle beta plus or minus phi. Beta is the impedance angle and phi is your load angle. So let's say we've got a lagging power factor, lagging behind IA. So there's V. Now remember, if we have a resistance in the circuit, in other words, ZS is equal to R plus JXS, then RA is always going to be in phase with the current. And IAXS is going to be perpendicular to the current causing it. And then that will be IZ. And then we've got E. And that is angle delta, which is our load angle. Okay. So that is for
Yes,
the
sir.
lagging power factor. Have you got that?
Yes, sir.
Right. Now for a leading power factor. Also, can you see here that E is bigger than V?
Yes, sir.
Right. So now let's say we've got V there and a leading power factor. Like so. Then the current is always going to be in phase with the current causing it. That will be IA, RA. And the angle will be phi. Here again, it will be phi there. And again, IAX is perpendicular to the current causing it. So therefore, IXS will be there. And that will be IZS. And then we get E and load angle delta. Here you can see that E is less than V.
Yes, sir.
And now, if you go to a unity power factor, then IA is in phase with V. Then we get the voltage IR there and IX there. IA, RA, IAXS. That will be IZS. And again, that will be E. And that is our load angle phi. Now E can now lie either bigger or smaller than V. It depends on how far the current or the impedance. What is the impedance angle? Now, if we are going and we make IA the subject of the formula, then we get E angle delta divided by Z angle beta, né? Minus V angle 0 over Z angle beta. So that means we have E over Z angle delta minus beta minus V over Z angle beta minus 0 minus beta. Now we are working with the conjugate of the current. And the conjugate of the current means that the angle changes now. So that will be E over Z beta minus delta minus V over Z beta. Okay.
Yes, sir.
So now we say that P is equal to E P developed is E times IA angle between E and I. Now, what we've done here is we've broken up the current into its two components. Normally, that will be V over Z and E over Z. And the sum of these two currents will make IA. So now, we can say P is E, and now IA becomes E over Z cos of beta minus delta minus V over Z cos beta. Because if we look at the phasor diagram like that, then we will have E there and V there and the current somewhere here. Now, if we divide E by Z, let's say that will be there, because that angle will be beta. That angle is delta. Anyone okay so far?
Yes, sir.
Right. And now if we divide V over beta, then we get it here. So that will be E over Z, and that's V over Z. Now again, this angle here will be beta between V and V over Z. And this angle between V over Z and E over Z is exactly the same as delta. Okay,
Yes, sir.
because those are the same, we've just moved them by dividing them by Z. Okay, now you can see there, if we stick there and we rotate this anti-clockwise, it means we get E, and the next component of the current that comes by is E over Z. Oh, asshole, I made a mistake here. That must be beta. Can you see?
Yes, sir.
Right, so remember, that's why I say never remember this stuff. Always try and figure it out quickly. And now, V over Z is going to be this beta plus delta. Do you agree? Because the angle between E and V over Z will be beta plus delta. You see that?
Yes, sir.
Right, now if we look at the output power has got to do with V, and therefore that will be IA's conjugate times the angle between V and I. So we got V, take Z out as a common factor. What do we get first? E over Z, no? So that's E. So what is this angle here? That must be beta minus delta. Can you see that? E, if we look at V, what's the angle between V and E over Z? It's that angle there. And because that is beta and that is delta, this must be beta minus delta. Can you see that?
Yes, sir.
All right, minus V cos, so that must just be beta. Okay,
Yes.
right. Now, the difference between, let's say, P develop minus P out is I squared R. That's what it is. Now, if we look, right, let's say we've got a large machine. Now, for a large machine, R tends to 0. In other words, ZS is now X, and that is JXS. Now, and therefore, beta equals to 90 degrees. Do you understand that? Because if you look at that, that's normally R and JX. That gives us normally that angle beta. But now there's no 0 R, so we only have JXS. And therefore the angle will be 90 degrees. Now if we look at P developed as E cos beta. How much is the cos of beta? Cos of 90. That is 1. Minus E cos of 90 plus delta. Now, if you remember back from mathematics 1 or preschool, that becomes minus cos sine of delta times V. So there we have EV over Z X, sorry, sine delta. And if we take the P out, this must now V over Z cos beta minus delta becomes sine delta. And cos 90 is 0 again. So therefore we can see that if we look at the large machine, the output and the developed power is the same because there's no I square R loss again. Teacher Beleng. Right. Anything more? Now all these problems in the book, whatever, they are there just to confirm this fact. And just remember, we can also write P out is VI cos phi, or cos angle between V and I. And the developed power is also E times I cos of the angle between E and I. So sometimes I can say, all right, use the long formula and develop the formula for the output or the developed power. Then you're going to start with that and do this, do that, and that. Now let's say we've got a 5 kVA 208 voltage 50 Hertz star connected alternator. ZS is equal to 0,1 plus J, 5. We must determine the output power and the developed power and all that. So first of all, we calculate I full load is divided by square root 3 divided by V line, which is, oh, Morgan's chair is breaking. That comes 13,88 amps. lagging at the power factor of 0.8 lagging. Now the induced EMF is going to be 208 divided by square root 3 on 20, 1 angle 0 plus 13,8 angle minus 36,87 times 0,1 plus j 0,5. Now if you calculate that, 120. I get about 126,44 at an angle of 2,1 degrees. So now, next step is I want to know what is the output power or the developed power, first of all. That will be E over Z cos E cos beta minus V cos beta plus delta. Okay, so that means we've got 126,44 and the Z is 0.51 at an angle of 78. So that is 126,44 cos 78,7 minus 120,1 cos 78,7 plus 2,1. So it's 126.44 times I get about 1,381,84. Now somehow we can check it quickly. P developed. EI because of the angle between E and I, 126,44 times 13,88 cos of 2,1 plus, because it's that way, and phi is that way, 36,87. So 126.44 I get with a round off or error of 136.5, which is close enough. Depending here how we round it off here and round it off there, but it's close enough. You agree with that? And then remember, Q is E over Z E square E minus V cos beta, I think. I can't remember. But you can derive it from there. Because Q developed will be E squared over Z cos beta minus EV over Z, sorry, sine beta, and Z sine beta plus delta. Okay, so the sine of 90 is 1. So we've got E squared over Z minus sine beta of delta becomes EV over X cos delta, because that's 90 plus delta. Okay.
Yes, sir.
Right. So these problems are as easy as that. You can either get one with a resistance or one without the resistance. And if you follow this rule, you will get every single one of them right. Okay, guys, any more questions? I think if you've got a question, you can either email me or you can wait for the next class and then ask them. From the beginning, any work. If you've got a problem, ask.
Okay, so we'll do so.
Right. Any more questions? Okay, guys, I'm going to send you this WhatsApp, this email, and then you can see. Okay, they say we're almost out of time. Okay, guys, good night. Sleep tight. Don't let the bugs bite. Condomize and what is
Hey,
the other
thank
one?
you, sir.
Washing your hands. Sanitize. Okay. Any questions? Okay. Good night. See you guys. I'll send you this now. Huh? Question?
Oh, no questions, sir.
Okay, I'll just let this thing run its course and then I'll email you the link.
Okay.
Okay, good night.
Good night, sir.
Bye-bye.
Thank you. Bye.